Hello everyone, in this video let us solve this question. So we have minus 7 all raised to power t is equal to 7. What is the value of t? So t is the unknown to solve for. To solve this solution, we have minus 7 all raised to power t is equal to 7. In this case, we're going to use two methods to solve this question. So two different methods to solve the question. So for the first method, first, we're going to write minus 7 as minus 1 times 7 all raised to power t equals to 7. So with this, recall that root minus 1 is equal to I. So if we square the both sides, we have in brackets square root of minus 1 all squared is equal to I squared. From here, square cancel square root, minus 1 is equal to I squared. So, in place of minus 1 right here, we'll bring in I squared. So this then becomes, in brackets, I squared to replace minus 1 times 7 all raised to power t is equal to 7. So from here, we're going to introduce logarithm to this equation. So we have logarithm of, in brackets, I squared times 7 all raised to power t is equal to log 7. And applying this rule of logarithm, that if you have logarithm of a raised to power b, this equals b times logarithm of a. Applying this rule right here, what happens is this: power t comes to this other side, and this becomes t times logarithm of I squared times 7 is equal to log 7. So with this, we can also apply this rule of logarithm, that if you have logarithm of a times b, this equals log a plus log b. Applying this rule right here, this then becomes t then multiplied by logarithm of I squared plus log 7 all is equal to logarithm of 7. So we can then divide both sides by log I squared plus log 7 over log I squared plus log 7, so that t can stand alone. So this will divide this, t will then stand alone, which equals, we have log 7 over logarithm of I squared plus log 7. Now, this can still be simplified further by applying this rule of logarithm, that if you have logarithm of a raised to power b, this equals b times logarithm of a. Applying this rule right here, the value of t is then equal to logarithm of 7 over power 2 becomes 2 times logarithm of I, then plus logarithm of 7. With this, we have gotten the solution of t for the first method. Now let us try the second method, whether we'll get the same solution. So for the second method, the question, which is in bracket minus 7 all raised to power t is equal to 7. From here, we're going to express minus 7 as minus 1 times 7 all raised to power t is equal to 7. Shows that if we apply this rule of indices, that if you have a times b all raised to power c, this equals a raised to power c times b raised to power c. Applying this rule right here, this then becomes, we have it as minus 1 raised to power t times 7 raised to power t is equal to 7. So at this junction, we are then going to apply the Euler's formula, which is given by e raised to power I times pi plus 1 is equal to 0. And from here, let us solve for e raised to power I times pi. So move plus 1 over to this side. We have it as e raised to power I times pi is equal to minus 1. Now looking at this, in place of minus 1, we can bring in e raised to power I times pi. So minus 1 right here can be replaced with e raised to power I times pi. This then becomes e raised to power I times pi, then all raised to power t times 7 raised to power t. This is equal to 7. So this equals 7. Now from here, we are then going to multiply this such that e raised to power I times pi t times 7 raised to power t is equal to 7. Now at this junction, we're going to introduce natural logarithm to this equation. So we have ln in brackets e raised to power I times pi t times 7 raised to power t is equal to ln 7. So with this, applying this rule that if you have ln A times B, this equals ln A plus ln B. Applying this rule right here, what we then have is this, that ln e raised to power I times pi t, then plus ln 7 raised to power t, this equals ln 7. So writing down ln 7. Okay, so from here we are also going to apply this rule also, that if you have ln A raised to power B, this equals B times ln A. Applying this rule right here and here also, what we have is this. So I times pi t multiplied by ln E, then plus t multiplied by ln 7 is equal to ln 7. Now at this junction, the value of ln E is equal to 1. So this becomes 1. So we have I times pi t times 1 plus t times ln 7 is equal to ln 7. Now, from here, multiplying I times pi t times 1, the value is I times pi t, then plus we have t times ln 7, t times ln 7, this equals ln 7. So, this is equal to ln 7. At this junction, we have a common factor which is t. So factorize out t from here. T into bracket, we are left with I times pi plus we are left with ln 7 is equal to ln 7. Now to then solve for t, simply divide both sides by I times pi plus ln 7 over I times pi plus ln 7. This we divide this, the value of t is then equal to ln 7 over I times pi plus ln 7. So from here, we have gotten the solution of t. So t equals to ln 7 over I times pi plus ln 7. Now this is the solution for t for the second method. While for the first method, the solution of t is this, that t equals to logarithm of 7 over 2 logarithm of I plus log 7. So these two solutions are the correct solution for the given question. So with this, I hope you all enjoyed the video. Don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.